Welcome back to today's class, which is the last part of coordinate geometry, and the subtopic is conditions for parallelism and perpendicularity. So we are going to recall that is the angle between two lines, angle between two straight lines. So we have tan alpha equals to absolute value of m2 minus m1 all over 1 plus m2 m1. So where m2 m1 are the gradient, so m2 is the gradient of the second line, m1 is the gradient of the first line, and alpha is angle between the two lines. So the condition for parallelism, so if two lines and then two straight lines are parallel, if two lines are parallel, then the angle between them is 0. So that is the angle between them is 0. So you can now say we can say therefore m2 minus m1 equals to 0. So m2 minus m1, that is the numerator of the right hand side of the angle between the two slopes. So m2 minus m1 equals to 0. Therefore m2 equals to m1. So for the two lines to be parallel to each other, it means the gradient of the first line equal to the gradient of the second line, or the gradient of the second line equal to the gradient of the first line. That is tan alpha. And for the numerator to be equal to 0, that's why we have m2 minus m1 equal to 0. So we have m2 equals to m1. That is the gradient of the first line equal to the gradient of the second line. So note that two lines are collinear. Two lines are collinear, or rather, 2 points are collinear. 2 points are collinear if the 2 points. So 2 points are collinear if the points lie on the same straight line. So 2 points are collinear if the 2 points lie on the same straight line. Then the gradient of the two collinear points are the same. So this is for parallelism. That is, recall that tan alpha equals absolute value of m2 minus m1 all over 1 plus m2 m1. So if two lines are parallel, then angle between them is 0. That is, m2 minus m1 equals to 0. So if m2 minus m1 equals to 0, it means m2 equals to m1 and tan alpha equals to 0, because 0 all over any number is what? Is 0. So we now note that 2 points are collinear if the points lie on the same straight line. Then the gradient of the two straight collinear points are what? Are the same. So that is that for parallelism. Then condition for perpendicularity. Condition for perpendicularity. So condition for perpendicularity. So if the two lines are perpendicular, that is the angle between them is what? If the two lines are perpendicular, that is the angle between them is 90 degrees. That is alpha equals to 90 degrees. Then tan 90 degrees equals to what? Infinity. And for tan 90 to be equal to 90, it means our denominator what? Our denominator is what? Our denominator is equal to 0. So we now have tan 1 plus m2 m1 equals to 0. So the denominator is equal to 0 for tan 90 to be equal to what? Undivided. So we now have m2 m1 equals to minus 1. Therefore m2 equals to minus 1 all over m1. So for perpendicularity, m2 equals to minus 1 all over m1. That is the gradient of the product of the two gradients must be equal to what? Minus 1. Or you can say m2 equals to minus 1 over m1. So this is the condition for perpendicularity. So we now move to the first example. So example 1 says, determine if AB is parallel or perpendicular to PQ in each of the following, and hence find the angle between the two lines. So we have two, number figure 1, we have 2 points, that is line AB, and we have line PQ. So for line AB, we have A of coordinate 3,1, B of coordinate 4,3, and point P, we have P of coordinate 4,6, and Q of coordinate 5,8. So solution, number figure 1. So number figure 1. So we are asked to determine if AB is parallel or perpendicular to PQ. So we are going to make use of the conditions for parallelism or perpendicularity. So for parallelism, so we are going to look for the gradient of the first line, which is AB, and the gradient of second line, which is PQ. So if they are the same, which means AB is parallel to PQ. So let's write out the point. That is point A is 3,1, and point B is 4,3. So then P of coordinate 4,6 and Q of coordinate 5,8. So we have x1, y1, then s2, y2. Then for PQ, we have s1, y1, then s2, y2. So let's look for the first gradient, that is m1 from line AB. So m1 equals to y2 minus y1 all over s2 minus x1. So m1 equals y2 is 3, so 3 minus 1, which is y1. Then y2, s2, that is 4 minus 3, so which is equals to 2 over 1. And 2 over 1 is what? 2. So M1 is 2. Then the second gradient, which is M2 from line PQ, so we have M2, which is equals to y2 minus y1 all over s2 minus s1. So which is gradient formula. Then from there, we have y2 to be 8 minus y1 6 all over s2 5 minus s1 4. So which is 2 over 1. And 2 over 1 is what? 2. So you can now say that M1, which is equal to 2, is the same thing as M2, which is also equal to what? 2. You can now say, therefore, M1 equals to M2, which is equals to 2. So since M1 is equal to M2, then since M1 equals to M2, then AB is parallel. So this is the sign for parallelism. So AB is parallel to PQ. That is, line AB is parallel to line PQ. So then the second part of the equation is find the angle between the two lines. So to get the angle between the two lines, we are going to make use of angle between two lines formula. That is tan alpha equals absolute value of M2 minus M1 all over 1 plus M2 M1. So we have absolute value of M2, that's 2, minus 2 all over sorry, 1 plus 2 into 2. That is M2 multiplied by M1. Then you close the bracket, which is equal to 0 all over 2 times 2, 4, 4 plus 1, 5. That is 0 over 5. Then we now have alpha equals to what? Equals to 0. Then if tan alpha is equal to 0, which means the angle between them is 0. Therefore, alpha will now be tan inverse of 0. So alpha will be equal to, tan inverse of 0 is 0. So it means angle between them is 0. So that is that on the first part of the question. That is we have go on. So we determine the parallelism or perpendicularity. Then we know the angle between the two lines. So let's move to the next question. So Roman figure 2. So Roman figure 2 says A of coordinates 5, minus 1, B of coordinates 3, 2, and P of coordinate 2, 4, Q of coordinate 5, 6. So just like the first question, we are going to determine the condition. We are going to determine whether the two lines are parallel or perpendicular to each other. So using the gradient to determine that. So we have x1, y1, then s2, y2 from the line AB. Then from line PQ, x1, y1, s2, y2. So M1 will be y2 minus y1, that is gradient formula, s2 minus x1. So which is equals to, what is our y2? That is 2 minus 1 all over 3 minus 5. So that is for the first line. Then we have M1 to be equals to 2 plus 1 all over minus 2. That is 3 minus 5 minus 2. So we now have 3 all over minus 2. So that is the gradient of the first, which is the same thing as minus 3 over 2. So M1 is what? Minus 3 over 2. So let's determine the gradient of the second line. That is for PQ. So now have M2, which is equal to Y2 minus Y1 all over S2 minus X1. So what is Y2? That is 6 minus 4 all over S2, that is 5 minus 2. So 6 minus 4, that is 2 all over 3. So the gradient of the second line is what? M m2 which is equals to 2 over 3. So as you can see, m1 and m2 are not the same because minus 3 over 2 and 2 over 3 are not the same. So we now check for what? Perpendicularity. And the condition for perpendicularity is that m2 multiplied by m1, their product must be what? Minus 1. So if the product of the two is equals to 1, so let's now check. Our m2 is 2 over 3. Our m2 is 2 over 3. Then multiplied by m1, that is minus 3 over 2. So which is equals to 2 times minus 3, that's minus 6, all over 3 times 2, that is 6, which is equals to minus 6 over 6, that is minus 1. It means the product of the two gradients is what? Is minus 1. We can now conclude that. So we can now conclude that line AB is perpendicular to what? Line PQ, because the product of the two gradients is equals to what? Is equals to minus 1. So the product of the two gradients is equals to minus 1. So since m2 multiplied by m1 is equals to minus 1, then line AB is perpendicular to line PQ. So that is the first part of the second question. That is what I got to. Then the second part is to look for the angle between the two lines. So what is the angle between the two lines formula? That is tan alpha equals absolute value of m2 minus m1 all over 1 plus m2 m1. So which is equals to m2. m2 is 2 over 3, that's 2 over 3 minus m1 minus 3 over 2. Then you close the absolute value, then 1 plus m2, that is 2 over 3 multiplied by minus 3 over 2. Then you close the bracket. So tan alpha equals to 2 over 3 plus 3 over 2. Then all over 1 plus times minus is minus. Then 3 here 1, 3 here 1, 2 here 1, 2 here 1. So that is 1 minus 1. So which is equals to tan alpha equals to. So let's look for the LCM. LCM is 6. LCM is 6. So 3 is 6, 2 times 2, 4, plus 2 is 6, 3 times 3, 9. Then all over 1 minus 1 is 0. So we now have tan alpha equals to absolute value of 13 over 6 divided by 0 over 1. So which is equals to 13 over 6 multiplied by 1 over 0. So everything is, that is tan alpha equals to undivided, because 13 times 1 is 13, all over 6 times 0 is 13 divided by 0 is undivided. So therefore, alpha will now be equal to tan inverse of infinity, so which is equals to 90 degrees. So the angle between them is 90 degrees. So that is that on question number 1 over 1 and 2. So we move to the next question. So example 2 says, determine if the points A, B, and C are collinear in A of coordinate 1, minus 1, B of coordinate minus 2, 4, and C of coordinate 0, 1. So don't forget the condition for collinearity. So the condition for collinearity is that for these 3 points to be collinear, they must lie on the same straight line and they must have the same gradient. So to determine whether they have the same gradient, so we are going to group them 2, 2. So we are going to group AB. So you group AB and BC. And if you like, you can group AB, BC, and AC. So these 3 points, they must possess the same gradient. They must have the same gradient. So let's test for AB. So the gradient of AB, so we have A of coordinate 1, comma minus 1 and B of coordinate minus 2, comma 4. So this is our x1, y1, x2, y2. So m1 will now be equals to y2 minus y1 all over x2 minus x1. So which is equals to y2, that is 4, minus y1, that is minus 1, all over s2 minus 2 minus 1. So which is equals to 4 plus 1 all over minus 3. So which is equals to 5 over minus 3. 5 over minus 3 is the same thing as minus 5 over 3. So which means our M1 is what? Minus 5 over 3. That is the gradient between the point, on the line AB. So that is for AB, gradient of AB. So let's look for gradient of BC. So gradient of BC, B is of coordinate minus 2, comma 4, and C is of coordinate 0, comma 1. So we have x1, y1, x2, y2. So from here now, M2 is the gradient of like BC. So M2 is the same thing as y2 minus y1 all over x2 minus x1. So which is equals to, so what is y2 from BC? So y2 is 1 minus y1, that is 4. So that is 4 all over s2. S2 is 0 minus x1 minus 2. So which is equals to 1 minus 4. 1 minus 4, that is minus 3 all over minus times minus, that's plus 0 plus 2. So which is equals to minus 3 all over 2. So minus 3 over 2 and minus 5 over 3 are not the same. So we can test for the third point or third straight line, which is AC. So A is of coordinate 1, comma minus 1 and C is of coordinate 0, comma 1. Then we now have x1, y1, x2, y2. So you can now see M3 is equal, that is the gradient of my AC. So we now have M3 equals to y2 minus y1 all over s2 minus s1. So which is equals to y2 is 1, so 1 minus 1 all over s2, that is 0 minus 1. So we now have 1 plus 1 all over minus 1. So which is equals to 2 over minus 1. And 2 over minus 1 is minus 2. We can see that gradient M1 is not equal to M2 and is not equal to M3, which means point A, B, and C are not collinear. Since M1 is not equal to M2, is not equal to M3, then point A, B, and C are not collinear. So they are not on the same straight line. They are not on the same straight line. So that is that on conditions for parallelism and perpendicularity. And this will be the end of coordinate geometry class. So thank you and God bless.